So first is starting Simon Morley on the UK high-speed railway track lifecycle management strategy. So I think around 15 minutes probably, and then followed by John Smith of First Alpine Signaling UK.
Good morning. It's nice to be here. I'm Simon Morley. I'm head of infrastructure maintenance here at HS2, and I've been with HS2 for about 7 years. My background, if you're wondering, is the launching girder for a long viaduct on our network. It will be Britain's longest bridge when it's built, Colne Valley Viaduct. I appreciate that a lot of the audience's first language isn't English, so I will try and slow down a bit as I go through these slides. So I have written the maintenance requirements for the railway across the line of route, so the routeway for all systems and the stations. So we look after the route and stations maintenance in the interim phase as assets are handed over, but also in the end state when we become an infrastructure manager. The phase we're in at the moment, I write the policy and the strategy, and soon we'll be writing the plans for the maintenance of the railway assets, as well as getting our organisation ready to work on those assets when the railway opens. So I'd like to thank the organisers and voestalpine for inviting me along here today to talk to you about HS2 asset management approach and how we're working with voestalpine to design and deliver modern, reliable and digitally enabled high-speed S&C. I'm going to take you through the approach, but before that I will give a brief summary of the project in the first couple of slides, and at the end of my slides I'll pass over to John Smith, who would take you through to the end of this slot. So on this slide you'll see the diagram on the right hand side showing the HS2 route. It links London in the south of Britain to Birmingham in the Midlands. From here the route goes further northwest, and it links on to an existing high-speed line, the West Coast Main Line, we call it, medium speed line theoretically. There are 4 stations along the route, 2 in the south and 2 in the north. The route is 224 kilometres. 51 kilometres of that is in tunnels, so underground. The line speed is 360 kilometres an hour, and we're building slab track as the track form with ETCS level 2 signalling. Here is the same route diagram, but I've shown with the red dot where our infrastructure maintenance depot is. I've written the requirements for this depot too. The depot is designed and we're waiting for a systems contractor to build it for us. So this is halfway along the route, and it's supported by smaller satellite depots to the south and the north. It's from here where all the maintenance will be coordinated and the renewals when the time comes. On-track machines, so engineering trains, will leave and return for overnight works, and those machines will be maintained here too. There are dedicated workshops for on-track machine maintenance. We've also specified a purpose-built training facility for HS2 on this site, and there is a connection to the national network from the back of the depot too. We have a rolling stock depot that's separate from the maintenance depot. And in the rolling stock depot, we have the control center, the dedicated HS2 route control center. It's in Birmingham, so it's at the northern end of the route. And it's here where the railway is operated from. 54 trains will be prepared and leave the depot in the morning and come back to the depot in the evening. They'll be maintained in the shed in the top picture you can see there on the left to keep the HS2 service running with a target average delay of 30 seconds per train. That's our target delay. So that's a bit about HS2 as a route and an infrastructure. I'm now going to go to describe our approach to asset management and maintenance on HS2. This is the approach that you see here on the left. This is the approach and the high-level summary of how we're going to approach asset management and maintenance across all systems, civils to railway systems to stations. But today, I want to specifically relate this approach to track and more specifically to S&C. So it provides a nice segue into John's presentation after mine. We have to take the opportunity to enable future safe operations and maintenance of the railway. This is one big opportunity. And the stage we're in at the moment, in the design stage, there's no bigger opportunity to design for maintenance. So design for safety in maintenance. At no other time in the railway's history, from this point forward, will we have such a big opportunity to make such an impact on the safety of our future workforce and our future generations that will work on the railway. And we must think of that long term. And I see that as my obligation and our obligation to take that opportunity today. If we don't take that opportunity, we'll miss that. So managing workforce safety through design is a massive day-to-day challenge for us. A large part of that opportunity, that design opportunity, is to create digitally enabled, integrated, and remotely monitored systems so that we prevent staff having to put themselves in danger to inspect the railway. It also allows us to maintain the railway with minimal disruption, because after all, maintenance in itself is a failure mode. Changing plans for maintenance and changing plans in general in the short term could themselves contribute to a higher safety risk. So this is a large part of the S&C system that is very important to us today as we work with voestalpine to design, install, and commission the S&C. And one, I must say that we're successfully navigating in the early stages of that contract for S&C. In fact, we're planning to inspect and monitor the railway using broadly 5 techniques shown here in this pie chart. And I want to start in the top left corner, the purple piece of section of pie there, the unattended measurement systems. And I'm going to take you around this pie chart and briefly explain what I mean. So the unattended measurement systems in the top left corner, we have 8 passenger trains fully fitted with track and overhead line measurement systems on them. So geometry and acceleration. They will monitor the track and the overhead line speed. 8 of the 54 trains. So we get good infrastructure coverage. Coming down to the left-hand side, we've got attended measurement systems on our works trains. So I'm writing the requirements at the moment for the on-track machines. And part of those requirements is to integrate monitoring systems on works trains. And the reason we do this is so that they can take measurements at slower speeds. So typical things would be ultrasonic measurements and rail head scanning and rail profile measurements. They will work within the OCS mast, the overhead catenary masts. They'll work mostly inside those, assisting not just with the inspection and monitoring, but with maintenance as well. At the bottom of the chart, in the green, you will see static infrastructure-based asset condition monitoring. This will largely consist of embedded sensor systems that will report asset condition and performance back to the control center in Birmingham, as well as to the engineers at our infrastructure maintenance depot in the middle of the route that I showed you earlier. And this is where the S&C system that we're building will excel, producing real-time data feedback and analytics to engineers for fault diagnosis and planning. Going back to Bjorn's presentation just a minute ago, it will also lend itself to the condition assessment of the infrastructure as well. And it's not just S&C, we've got this infrastructure-based monitoring on either. Coming further back up to the right-hand side, the blue section is what I'm calling our attended, but autonomous and slightly remote monitoring around the infrastructure. And these mainly consist of unattended aerial vehicles, drones, satellites, and webcams. So it's those other systems that can help remove people from the infrastructure and be able to measure condition. In the top right, we have the good old visual inspections. These are a necessary last resort for us. We should be putting people out on the infrastructure as a last resort for our monitoring capability. It's essential that people go out on the infrastructure, so I don't think we'll ever get away from not putting people on the infrastructure, because it's essential that people go out and look at the context of the assets and the environment that they're in and what's happening around that environment. We won't be able to solely rely on technology, and nor will we even want to in some respects, in some areas, but we should aim to minimize visual monitoring and people going into areas of danger wherever we can. And that brings us all the way back to that first principle of designing for maintenance and designing for safety. Of course, all this won't be possible without people. And on the left-hand side of this slide, you will see typical railway organisations and teams that you would find on a railway to maintain the railway day to day. But in the purple circle, I just want to call out an infrastructure support team that we're designing and we specified part of our control centre for. This team will include diagnostic and technical support, dedicated data analysts to allow us to understand all the data that's coming back to the control centre and going off to the maintenance depot. These people have a dedicated room. They're called, you could relate them to the term flight engineer. So they're the day-to-day people that will be monitoring all the data coming in from the assets out in the infrastructure. These people are co-located with other operationally critical roles, such as traffic management controllers, signalers in an old phrase that we use, and infrastructure management controllers too. They will be responsible for the continual monitoring of the railway assets through the data streams that will be fed to them continuously. So they're our flight engineers, and their job will be to identify emerging trends, conduct analytics, merging several sources of data together, not just from the assets and the physical infrastructure, but from other data that's coming in from elsewhere. It could be the public reporting faults. It could be weather data that's all going to come into this room to get an overall picture of the health of the railway. They will work in near real time, but will have the ability to project further ahead for longer term planning. So we've got the requirements, we've got the physical assets, we've got our plans and strategies, but we've also got the people to bolt onto that as well. And as S&C is a safety and operationally critical asset, this infrastructure support team will know the S&C assets intimately and be able to spot the slightest change in asset behaviour and condition. So as well as having modern reliable, digitally enabled S&C asset on the railway, we have designed and awarded a through-life technical support arrangement too, to assist our own internal resources in the effective and efficient management of the S&C along this route, and we have a large amount of S&C. voestalpine will support us in the following ways to ensure we have the right people doing the right things at the right time with the right skills and knowledge. In the bottom right-hand corner in the blue box, we've used the UIC maintenance level definitions as a guide while designing the responsibilities and the RACI in the support structure between HS2 and voestalpine. So now we have the physical assets, we have the strategies, the plans, we have the people, and the through-life support for making sure that this asset is as reliable as it can be throughout its life. So in summary, we're working with voestalpine to deliver a high-performing, reliable product, which is not only delivered through product design, installation and commissioning, but also continuing through the operational life of the asset. End user engagement in this approach with the supplier at an early stage was and still is very beneficial and allowed us to explain our approach and our requirements, which were then optimized through collaboration and the forming of good working relationships. This collaboration involved a joint assessment for a risk-based approach to monitoring of the S&C asset. That risk-based approach took into account things like impact of failure, geographical location, the speed of the track, and the tonnage that's going to be using the track. This will lead to an increase in the amount of decisions being made based on data and insights based on asset performance, which will optimize our spending profile and optimize the point at which we renew, going back to Bjorn's presentation a little bit earlier. And we will continue our journey with voestalpine during the period of time before operations, where we are now, but also long after the railway has been delivered into service, to provide a safe, reliable asset that enables staff to understand how the asset is performing and its condition from a remote location. Staff won't have to attend site so regularly. And when staff do attend site, they have the full knowledge of how the asset is behaving and what needs to be done to maintain its performance before they get there.